Hello and a warm welcome to our Unity game development series. Today's video is all set to be an exhilarating deep dive into combat mechanics in RPG development. We're not just going to talk theory, but we're showcasing practical action-packed development steps. Today we're introducing a crucial component to our combat system, the skeleton class for our fighter. This class will act as the core structure for our dynamic combat functionalities, and we're going beyond just framework creation. We will also demonstrate getting our character into prime position for delivering some hard-hitting combat moves. It's all about strategic positioning with thrilling combat action. Watch as we strategically maneuver our character into the heat of battle. It's the blend of tactics and action that breathes life into RPG combat. But before we start our coding adventure, I've got some exciting news to share. Unity's New Year sale is on, and it's packed with amazing deals. I've already snapped up this incredible Dead Knight character for our series, and I'm eyeing this fantastic dungeon pack next. I'll be adding links to both the Dead Knight asset I got, as well as the dungeon pack I plan to get, along with a link to all the amazing deals Unity has in store for you until the end of the year. Now, gear up for an action-packed tutorial that's going to take your RPG combat skills to the next level. Whether you're honing your existing skills or just starting out, you're in for a real treat. Let's get into the exciting world of Unity combat and give our character the possibility to get close to its enemies. Alright, let's get our game plan in place before diving into the coding. Today, we're conceptualizing our fighter class. This class will be the powerhouse of our combat system, responsible for moving our character to the target, facing them in the right direction, and of course, landing those impactful hits. Our first challenge is determining if we found the target. To solve this, we're going to employ a handy Unity method, Physics.RaycastAll, and we're passing in the point where we click. This method is like casting a net to see what we catch. It sends out a ray and returns all the objects it hits along the way, sort of like a radar scanning for objects in its path. But how do we shift through these hits to find our actual target? The answer lies in creating a new script. Let's call it CombatantMarker. This script will be attached to potential targets. When our fighter class checks the hits from our raycast, simple, it will look for the CombatantMarker component. Finding this component on an object is like our fighter saying, aha, there's my opponent. And once our fighter identifies its target, it's time to move in and, well, let's just say politely introduce its fist to the target. So that's our plan for the fighter class. It's not just about throwing punches, it's about smartly identifying who to throw them at. In our next segment, we'll jump into the coding and bring this plan to action. Let's get ready to rumble in the world of Unity coding. Okay, so here is where we've left off last time. Now, if we right click on the scripts folder, new folder, let's call it combat. And in here, we need to create two scripts. Let's say combatant target.cs, don't forget that. And again, right click on combat, new file, and let's call it fighter.cs. Let's start with the combatant target because this is the easy one. We need to do using Unity engine and also create the class. Now, remember that this will be under a namespace. So we should do namespace rpg.combat, and we open the brackets, and in here we should do public class combatant target and inherit from the mono behavior. It added something extra here which we don't need. Okay, so this is our combatant target for now. Now let's head on into the fighter class, and in here we need to do a few more things. So let's do using system.collections. So let's add these, as well as using collections.generic. So we basically need more stuff in here. Using Unity engine. If you did this from Unity, it will add them already for you, but I just like to work like this. So then we require for the fighter, because the fighter needs to get to the target, we require some stuff from the RPG.movement. So we include those as well. Now, What else do we need? Let's check the player management. So the player management has this movement methods here, but we're going to interact with the combat. So we're going to create a private bool combat. For now, let's return false because we're gonna fill it in a moment. So we're going to need this as well. Now, back to the fighter. Let's first add the namespace. Combat. And open the brackets. Oh, we forgot to add the using RPG.management. So we require that. And let's create a class. So public class fighter. We inherit from the mono behavior. Again, it added something extra. Let's delete that. And in here for now, let's see what variables do we need. First of all, we need a weapons range. So let's serialize a field. Let's do private float weapon range. I would do 2 for now, and we can adjust it in the editor. We also need a target. We need the mover because we want to move the player to the target. So mover. Let's add private to these so it looks cleaner. Okay. And we also need in the future an animator. Let's add a comment, add an animator in here. But for now, we're not going to do that. And in the private void start, we need to get the component for the mover. So mover equals get component, and we check for the component mover. Now, in the update method, so private void update, let's see what we need to do first. First, we need to check if we have a target. So if target not equals to null, so if we do have a target, we want to check if in range. Now, how can we determine if a target is in range? That's super easy. Let's create this in range method here. So it's private bool in range. Open the brackets. And in here, we need to return vector 3.distance. And we need to pass in the transform of the player. So transform.position. And also the target.position. Now, we also need to check if, so more than, it's smaller than weapon range. So if the distance from the player to the target is smaller than the weapon range, so in here, that means we want to cancel the mover. So mover.cancel. We don't have the cancel method yet. We're going to implement it in a minute. But for now, let's implement the logic here and then move to the mover script. Otherwise, so if it's false, if we're not in range, we need to call mover.move to target and pass in the target.position. We don't have this method either, but again, for now, we're just trying to figure out what we need to do. Now, once the player reaches the target, so we cancel the mover, and we also need to implement an attack behavior. So in here for now, let's go here. The attack behavior for us would be of type return type void. So attack behavior. And once we get to the target, we need to face the target. So we can do that simply by doing vector 3 target position equals new vector 3 target dot position dot x transform dot position dot y. We want to keep the y positioning the same as the player, so it doesn't kind of rotate and look to the sky. We should leave it like this, and then do target.position.z. Now we have the target position adjusted with the position on y. We can do transform.position look at and pass in that target position. Okay, so we've implemented this. Now we need to move to the mover class. Let's head over there. And in here, we need to implement move to target. We have this move to destination, which maybe, let's use this one. Actually, let's go back to the fighter, and instead of move to target, let's do move to destination. And go back here, we need to implement only the cancel method. So let's do a public void cancel. And in here, we need to stop the agent. To stop the agent, we can set agent that is stopped to true. Now, if we only do this, the move to destination will, the actual set destination won't happen anymore. So we need to reset agent is stopped here to false. Okay, now back in the player management script, we need to add another condition here. So if combat, we don't want to execute the movement, so we should return. Now in the combat method, we need to do some raycasting. So we would call a raycast hit, and we give it a list. So this will be a list, and let's call it hits equals Physics.RaycastAll. And in here, we need to pass array like before in the movement. So for now, let's do get mouse array. And instead of having it here, we can actually move this. So we take this out and we create a new method. Let's call it, it will be of type array, return type array. And let's call it get mouse array. And in here, we pass in a return, and what we cut, now we paste it here. So we have get mouse array here, and now here where we create the array in the movement on line 19, we can call get mouse array, because we require exactly the same thing. We need the array cast from the mouse position. So this is fine. Now that we have all the arrays, all the hits that this array is getting, we need to go to each one of them. So for that, we're using a for each loop. So for each raycast hit, let's call it the array in hits. And in here, we said in the slide that we're looking for the combatant target. So combatant target, let's call it target, equals ray dot transform dot get component, and we're looking for the combatant target. Now, if you notice, we are missing something from here, because combatant target and also the combat, basically the fighter, is in the namespace of combat. We need to use, we need to use that namespace, rpg.combat, so we can have access to this combatant target. And now that we have the target, so let's not forget the column over there, we can call if target is null, then we continue, because basically it's not a target. Otherwise, if input dot get mouse button, exactly like before, open the brackets, we need to get component, the fighter, so we're getting the component on the player, and we want to call attack, and we pass in the target. Now, after all this, we can return true. Otherwise, we return false. That's great. Let's look at the fighter to see if we have the attack method. It seems like we don't, so let's create it. So it's a public void attack, and we pass in a combatant target, and let's say combat target. Okay, so now in the attack method, we need to set target. So target here equals to the combat target dot transform. Awesome. Now that we have the target transform, we are moving towards the target, and when we get there, we cancel the mover, and then we do the attack behavior, which for now is just looking at the target. In a follow-up video, we're going to actually attack the enemy. We also have a small issue, and we're going to solve it properly in the upcoming video, which is going to be about interfaces. For now, let's create a public void cancel here, and we set the target equals null. When do we want to do this? So for now, we can actually do it after the attack behavior. So we cancel the mover, we do the attack behavior, which is to look at this enemy, and then we want to cancel. Otherwise, if we don't do this hack now, we will have to, basically the actual player is going to stay very close to the enemy forever. It won't try to leave at all. So for now, this is just a hack. In the follow-up video, we're going to fix it, so don't worry about it. Okay guys, I know this was long, but we're almost there. Now, before we go forward, please make sure you hit that like button and subscribe to the channel if you enjoyed this video. This will help us share this video with more people. Now, the final things we need to do is to easily just add the fighter to our player, but this is the target, so let's go to the player. Let's add the fighter script, and also go to your target and make sure to add the combatant marker. Combatant target. Now, let's hit play and see what's happening. So we can still move like usual, and if we click on the target, our character is gonna go, but I think because I have too much speed, it's not gonna stop where we want to. So if you go to your player and set this up to 3, it will give it more room to stop. And now hit on the target, and boom, it stopped. And now we can move away. And also let's do it again to the target and stop. Thank you so much for joining me today. Remember, every line of code you write, every problem you solve brings you one step closer to bringing your game to life. Keep coding, keep creating, and keep sharing your passion for game development. Until next time, keep leveling up your coding skill and stay tuned for more Unity RPG development adventures. Happy coding, everyone!